Hi guys, welcome to another Android development tutorial. Today I'm going to be showing you the basic fundamentals of writing code inside of Android Studio's code editor. Now, unlike some past tutorials, this one will be relatively simple because all that is needed to be able to follow through is just an installation of the Android Studio IDE. No prior programming knowledge is required, and you don't have to know much about Android Studio either. With that said, alrighty, let's get to it. So before we get started working in the Android Studio code editor, let's go ahead and take some time to consider what a basic code editor actually is. A code editor is just a tool that allows you to write, edit, or even delete lines of source code or even files that your application uses in order to run. Two examples of some code editors would be Don Ho's Notepad++ or Adobe Systems Brackets, both of which happen to be freeware. As it happens, Android Studio comes with its very own built-in code editor tailored specifically for building apps for the Android platform. Let's have a quick look at the four main pieces that help make the editor the editor. The first would be the Document tabs region, where the file with your source code is given a tab with a unique name. Now, if you were to have multiple files open simultaneously, then this is where you'd be able to switch between them, which could be done either by selecting a tab from the region or by pressing the Alt left or Alt right keys on your keyboard. The tabs could also be used to split up the editor's window, but we'll see an example of that later. Now, the second piece is the gutter area region. This is where some of the editor's control features are at. If you needed to toggle some breakpoints in your code for debugging reasons, or let's say maybe if you wanted to manually show specific functions so you could see them while hiding others, then this would be the place to do so. Again, don't worry if you don't already know what any of these tasks are. We'll be going over them as soon as we return to the Android Studio. Now, the window is the third main portion of the editor. It's basically where all the app's source code is written. The sidebar is the fourth and final piece of the editor. This is what you'd use to navigate to certain areas inside of your source code. Now keep in mind that there's much more to this sidebar than just the simple ability to navigate, as we will see later in this tutorial. Alrighty, so now that we've seen some characteristics of the editor, let's go on ahead and return back to the Android Studio so we can begin our work with it. Give me a sec. Alrighty, welcome back to the Android Studio. So to use the code editor, we'll need to open up a project source code file of some type. For the sake of this tutorial, I've already created a 3-activity example app with 3 source code files per activity. I'll go ahead and open up all 3 of them so you can see how the code document tabs region works. I'll also minimize the Project Explorer and the remaining windows. Okay, so here's Android Studio's code editor, and there's the document tabs region here, where you can pick between each of your app's source files. Now, as I said before, you could also use these tabs to split the editor window into separate sections so that each section shows a different file. To do this, just right-click on any tab in the tabs region, and you should be prompted with a menu. Now, the screen recording utility that I'm using for this tutorial doesn't allow me to film multiple windows within the same session, so I drew up this image here to show you what the menu would look like. Okay, so there are 2 ways you can split. You can either split the window horizontally, or you could split it vertically. I'll go ahead and select my first activity source code file. Perform a vertical split on the second file using the steps that I outlined in the previous illustration. And I'm going to perform a horizontal split on the third file. Keep in mind that if you ever wanted to reverse a window split, then the way to do so would be to once again right-click on the same tab that you chose before, except this time you should see a new option called the Unsplit Menu option, which can only undo a single split. If you perform more than one split, then you would also see the Unsplit All menu option there, which you can use to undo every split entirely. Now I'm going to reverse both splits and restore the editor to its former condition using the two steps shown in the previous scene. Because I no longer have need for either of the splits I performed earlier, I'll go on and select the menu's Unsplit All option. Okay, since I'm using the Unsplit All option, it really doesn't matter which of the three tabs I use to open the menu. Alrighty, so below the document tabs region on the left hand side will be the gutter area region here. As I've said before, this is where you'd have a little more control over each of your program statements. Now there may be some circumstances where you might want to pause your app's execution at a particular line of code for certain debugging purposes. Let's say maybe if you wanted to check the value of some variable just before or after it's used, or maybe if you wanted to stop execution at a particular function to see how well that function behaved, then you could definitely use breakpoints for that. Now there are 4 kinds of breakpoints and each serves a different purpose. The first will be the simple breakpoint here. Just so happens to be the easiest to use. Whenever you set a simple breakpoint, then that breakpoint will continue stopping your app's execution until you decide to manually remove it. Now there are 2 ways you can set a simple breakpoint. You can either click inside the gutter area next to the specific line of code that you want your breakpoint to be, or you could just select the code line using your cursor and then navigate the toolbar. You'd want to go to Run, then a drop-down menu should pop up, and then you'd want to choose the Toggle Line Breakpoint menu option here. So to illustrate the concept of breakpoints, I've added some code to my second activity file, main activity 2. This code is very simple. It just performs some basic arithmetic on 2 variables using 4 user-defined functions, and then prints the answers to the debug window. I'll go on ahead and run this source code without adding any breakpoint to see what it produces in the app's console window. Give it a sec. Okay, so if you check these console lines below, you should see 4 lines, each with a different function name and also a calculated end result of the integers 2 and 5. These lines here. Now upon checking the console lines more closely, you should also see that there's something not quite right with the last calculated line. 5 divided by 2 is not 2.0, it's 2.5. So something went wrong with the division function, function 4. So now that we know there's a problem, let's go ahead and insert a simple breakpoint to see if we can determine exactly what that problem was. Now, as I mentioned before, my screen record utility doesn't display windows within windows, so I'm going to use the first approach at setting this breakpoint. Let me just close this right here. Which is by clicking a line inside the gutter area region. I'll go ahead and click my cursor on code line 51, which in turn should create an icon in the form of a red circle like this one here. That icon lets you know that your breakpoint has been set. Now this also happens to be the line where the quotient of the 2 integers is returned after being calculated. But please keep in mind that in order for any sort of breakpoint to actually work, you need to run your app as a debug rather than just a general run. To do this, just select the green bug icon in the icon toolbar, this one here. When you do, you should be prompted with a window that looks somewhat like this one. You'll need to have at least one properly configured physical device or AVD that you could use to debug your app with. And once you select it, then you click OK. Alrighty, now that we've ran our app as a debug, rather than checking the app's general run console, we'll need to check the Android Studio debug window instead. If the debug window doesn't open automatically, then you can open it by clicking the debug button below the code editor window here. Doing so should produce this little window down below. If you don't see this section here, then you'll want to select your debugger tab. Now, because this is a simple tutorial on getting started with the code editor, I won't be going over the more advanced features of this debugger tool. For now, let's just focus on a basic piece of this useful tool, the variables column here. Now, if for any reason you don't see that column and you're running Android Studio IDE version 3, then you can open it by clicking on this icon here. Now what this column does is it tracks each value of every variable in your app's code up until the inserted breakpoint is reached. Because there are very few variables in this particular app example, these three are the ones we should be seeing. Now what this tells us is that at the time of the executed breakpoint, function 4's parameter x was passed a value of 5, parameter y a value of 2, and the quotient variable was also given a value of 2 following the division of the parameters on line 50. So the problem had to have happened sometime before that. In this case, those problematic lines are lines 48 and 49. These two, where the function parameters and quotient variables were first declared. Remember that integer variables are not large enough to hold any decimal number with the remainder. So to fix the issue, we need to change the data type of the quotient variable and the function's parameters from integer to double. Of course, we won't know if our problem is fixed until after we've checked the console output. So I'll go ahead and remove the simple breakpoint I set before. The easiest way to remove any breakpoint is by re-clicking the red dot icon inside the gutter area region like we did before. And when you do this, the icon should then vanish, like so. Now I'll go on and rerun the app's source code like before. Instead of running it as a debug, we can just run it as a general run. Which of course means that we don't have to check the debug console, we can check the run console instead. Alrighty, so after rechecking the run console lines, we should see that this time the quotient returned from our division function is now 2.5, as it should be, which of course would mean that our problem has indeed been fixed. The second type of breakpoint is the method breakpoint. Now this breakpoint behaves just like the simple breakpoint, except rather than stopping your app's execution at a selected line, it instead stops execution at the end of a selected function. To set a method breakpoint, first you need to take your cursor and select the code line that contains the method signature you want your breakpoint to be placed at. Next, you'll want to navigate your toolbar, go to Run, and then select Toggle Method Breakpoint. Once you do, it should place a red diamond icon inside the gutter area region, like this one here. Now the temporary breakpoint is the third type of breakpoint. Just like the first two, This one stops your app's execution at a selected line of code. However, unlike the first two, this type of breakpoint will only stop execution once. What this means is that after a temporary breakpoint performs its job, it will be removed automatically by the IDE until you decide to manually set it back again. Setting a temporary breakpoint is just as easy as setting the other two. Just highlight the code line where you'd like your breakpoint to be, navigate the toolbar, go to Run, and choose Toggle Temporary Line Breakpoint here. The last type of breakpoint is called the conditional breakpoint. This one performs the same way as the first three, except rather than just stopping an app's execution, it instead evaluates a user-defined conditional expression to determine whether or not the breakpoint should actually take effect. Thankfully, setting a conditional breakpoint is just as easy as setting the other types. The first thing you need to do is set a simple breakpoint first by clicking inside the gutter area next to the specific line you want your breakpoint to be. You should then see a red circle icon like you did before, except this time what you'll want to do is right click on that icon to bring up this little pop-up menu here. This is where you would enter in your conditional expression test, and once you do, you can close this menu by clicking the Done button. The red circle icon that you saw earlier should show a tiny question mark in front of it, like this one here. That lets you know that your conditional breakpoint has been set. Now, if the entered conditional expression evaluates to a value of true at the exact time the conditional breakpoint is reached, then that breakpoint will take effect by stopping your app's execution. However, if the expression were to instead evaluate to false, then what would happen is the breakpoint would not take effect, and the app would continue running in debug mode as if the breakpoint had not been set in the first place. Alrighty, before we move on to the next piece of the Android Studio code editor, let's go ahead and check out one more useful feature of the gutter area region, and that is its function folding ability. To illustrate this feature, I'll go ahead and switch over to my main activity 3 Java file. This particular file doesn't actually do anything, it's just a dummy source file with some dummy functions, each function with a different name ranging from function A to function Z. This dummy file serves as a basic example of what real source code would look like if you were writing a significantly longer activity file for a more complicated activity. Now, the complexity of your app project may require you to write dozens of functions, which can make navigating through your code difficult or overwhelming. That's where the feature of folding and unfolding comes into play. So what folding and unfolding generally is it's a mechanism that allows you to choose what specific functions you actually want to see while also hiding the ones that you don't. Now, there are two ways that you can use this feature. You can either fold and unfold manually by clicking the markers inside the gutter area region, these right here, or you could just fold and unfold everything so that every function is either shown or hidden all at once. To do this, you would need to press the needed keys on your keyboard. It would be Control-Shift-minus to fold all the functions. And it would also be Control-Shift-plus to unfold all the functions. I'll go ahead and show you a quick example of function folding and unfolding. What I'll do is fold every function from A to Z using the keyboard shortcut Control-Shift-minus, like so. Alrighty, now every function block has been hidden between each set of curly brackets. Now I'll go ahead and unfold some functions, but rather than simply unfolding everything, I only want to see the functions D, F, and K. So I'll leave all the other functions folded. Okay, so now we can shift our focus over to the editor window, which should be to the right of the gutter area region. As I've said before, this is where an app project's source code is written. Just like the gutter area region, the editor window also has some built-in features which can help make writing your code a little easier. A good example would probably be the editor's code completion feature. Now what this does is it scans the text from a program statement that is currently being typed and generates a pop-up list of suggestions you could use to complete that program statement even before you finish typing it. You can navigate the list using the up and down arrow keys, and if you see an option you like, then you can select it by pressing enter. The list itself usually appears automatically, but you can also open it manually by pressing the Control Space keys on your keyboard. Another useful feature would be the statement completion feature. Keep in mind that statement and code completion are not the same thing. They're two entirely different things altogether. Remember that code completion makes typing lines of code easier by generating pop-up lists of suggestion options. But statement completion does not generate any list of suggestion options. What it does is it scans a highlighted code line for an incomplete control structure missing either a parenthesis or bracket, and then automatically inserts the missing parenthesis or bracket for you. Statement completion is mainly used for filling out simple control structures like loops or even functions. You too can use this feature by pressing the Control-Shift-Enter keys on your keyboard. Before moving on, I'll go ahead and show you a quick example of the statement completion feature. For this example, I've added some code to my first main activity source file. It's pretty straightforward. What we have here are 3 different loops and also 3 different functions, all of which happen to be incomplete program statements. Let's go ahead and look at the loops first. The first is a for loop that's only missing a closing curly bracket, but we can insert it by highlighting the loop's code line and pressing the keys Control-Shift-Enter like so. Okay. Of course, we could have also typed in the missing bracket, but right now that's not really the point. The second loop is a while loop that's missing a closing parenthesis in both brackets. I'll go ahead and use statement completion to insert them. Highlight, Control-Shift-Enter. Okay. The third loop is a do while loop missing both brackets and both parentheses. Once again, highlight and Control-Shift-Enter. Okay. In the case of the do while loop, it also inserted the while keyword for us right here. Alrighty, now on to the functions below. Function 1, missing only a closing curly bracket. Highlight, Control-Shift-Enter. Function 2, missing both curly brackets. Highlight, Control-Shift-Enter. Function 3, also missing both curly brackets and a closing parenthesis. You guessed it, highlight, Control-Shift-Enter. Alrighty, one last feature of the editor window would be the document lookup feature, which would allow you to view information on any specific predefined class or function of your choosing. It's actually quite easy to use. You first need to hover your mouse cursor over the class or function you want to look up, and then press the Control Q keys on your keyboard. When you do, it should bring up a window like this one here. Now, if you were looking up a function, then a few examples of the information you'd find inside this window would probably be the function's description, the return type, and also the function parameters. But if you were instead looking up a class, then you'd probably see just a lengthy text description plus some minimal details about the class itself. You might find the class's parent, or even the specific package that the class is in. Before wrapping up this tutorial, I'll go on ahead and tell you about the last piece of Android Studio's code editor, and that would be the editor sidebar, which should be located to the right of the editor window here. This sidebar can be used to navigate to different areas in your code. Now, as I mentioned before, this isn't your typical sidebar. There's a little more to it than just the ability to navigate. As it turns out, Android Studio's built-in code analyzer tool is just one feature that helps make the sidebar unique. Now what the code analyzer tool does is it scans every line of code written inside your source file for warnings and syntax errors, and then generates a small tally on the occurrences of each, like this one here. Okay, if for some reason you are unable to see this tally, then you can hover your cursor over the indicator icon in the top right corner of the editor window to open it. Now that indicator icon can take three forms. The first form would be the red alert. You'll usually see this if the code analyzer comes across at least one syntax related error. The second form would be the yellow square. You'd see this if the analyzer came across at least a single warning but no syntax errors. And finally, the third form, the green check, which means that no warnings or syntax errors were found after the source file was scanned. Now let's say maybe you check the indicator icon and you noticed either the red circle or the yellow square. Then what would happen is the analyzer tool would then insert a series of colored markers within the sidebar, each marker being located at different areas in your source file where the issues had been detected. If you were to hover your cursor over any of these markers, then you'd probably see pop-up messages like this one that give you a small description of why the marker had been placed there in the first place. Well, there you have it. That pretty much concludes this tutorial on the Android Studio code editor. The more you play around with the editor, the more comfortable you will eventually become. Happy coding and best of wishes.